Hello everyone. Our today's lecture is about insertion sort algorithm. Insertion sort algorithm in data structure is another sorting technique that we can use to arrange our data elements either in ascending order or in descending order. This algorithm works in such a way that it picks up a particular value or a data element and then inserts that element at an appropriate place in the sorted sublist. Okay, so initially what we have an unsorted list of numbers. Suppose we have unsorted list of n numbers, and let me represent that unsorted list in an array form as a0, a1, a2, so on up to a n minus 1. So we have an unsorted list of n numbers, and as per this insertion sort algorithm, what this algorithm does, it takes out the first element out of this list and places it at an appropriate place. Suppose we keep it here like this, and then this algorithm takes out another element out of the unsorted list, and this element is compared with the already existing element in the sorted sublist. We can write this A0 as sorted sublist because it has nothing to compare with. It is a single element and we can write it as sorted sublist. And when this algorithm takes out the next element out of the unsorted list, that is A1, then A1 is compared with A0, and if A1 is greater than A0, then this A1 is placed on the right side of A0. That is, if it is greater than A0, then we place A1 here. Okay, and if A1 is less than A0, then we place A1 here. So these are the two appropriate places for A1, but it depends on the situation. It depends after comparing A1 with the already existing element in the sorted sublist. Okay, suppose we see that this element, that is A1, is greater than A0, then we will place it on the right side, and we will remove this element which we have placed on the left side. Okay, then this algorithm picks up the next element out of the unsorted list, and then this A2 element is compared with A1. If A2 is greater than A1, then A2 will be placed here at this place. Okay, and if A2 is less than A1, then another comparison is made between A2 and A0. If A2 is greater than A0, then we will place A2 at this place, that is in between A0 and A1, and if A2 is less than A0, then A2 will be placed on the left side of A0. So in this way, we move ahead in the algorithm until we reach at the last element in the unsorted list, and ultimately by following this procedure we get a sorted list of elements. Okay, now I will take an example of some unsorted list, and we will undergo by executing this procedure or this algorithm, and we will come to know how this algorithm actually works. As for the understanding of this algorithm, we are using iterative method to understand the working of algorithm, and in iterative method we have different number of rounds. Now for example, we have an unsorted list of elements. Suppose we have 35, 20, 40, 100, 3, 10 and 15 as unsorted list of elements, and we have to sort these elements in ascending order by using insertion sort algorithm. As we are using iterative method to explain this algorithm, there will be different number of rounds or iterations. So in the round 1, what I will do is I will take out the element at first position, that is 35. Okay, 35 is taken out of the list, and let me place 35 here. Okay, and as this is a single element and it has nothing to compare with, so it is a sorted element or a sorted list, and rest of the elements will be placed like this. Let me put this list in an array form. Now in the round 1, out of this unsorted list, we will take out the second element that is at position A1, and it has a value 20, and this 20 is compared with the element at position A0 in the sorted sublist. That is, this 20 will be compared with 35, and yes, 20 is less than 35. Okay, so 20 will be inserted at position A0 and 35 will move ahead to the position A1. So I'll write here, since A1 is less than A0, that is 20 is less than 35. In that case, this algorithm says insert element A1 before A0, and after doing that we will get another list that is shown in the round 2. Now in the round 2 we take out the next element that is at position A2. Okay, and the value of this element is 40. This 40 is compared with the element at position A1, and we see that the element, this 40 is greater than 35, so there is no need to perform any action because this is already in the sorted form, or you can say in the ascending form. So I'll write here, since A2 is greater than A1, so therefore it is already sorted and no action is performed, and we get a new list that is shown in the round 3. Now in the round 3, this algorithm takes out the next element that is at position A3, and it has a value 100. This value 100 is compared with the already sorted elements which are at position A2, A1 and A0, and as we see that 100 that is at position A3 is greater than the element at position A2 which is 40. So here again there is no need to perform any action as it is already sorted in the ascending order. So I'll write here, since A3 is greater than A2, and again there is no action required, and we get a new list that is shown in the round number 4. The elements that I am showing in the green color, they are also called as the sorted sublist, and the elements which are in the red color, they are considered to be the elements that we have to sort by using this insertion sort algorithm. Okay, now as per this algorithm, what we have to do is we have to select the next element in the unsorted list, that is 3, and we will write it here, and this 3 is compared with the other elements which are already in the sorted sublist. 3 is compared with the element at position A3, and we see the element, that is 3, is less than the element at position A3, and also it is less than the element at position A2, and also it is less than the element as position A1, and also it is less than the element at position A0. So I will write here, since A4, that is having value 3, is less than the element at position A3, A2, A1, and also it is less than A0. So therefore insert element A4 before the element at position A0. Okay, and we will get a new list that is shown in the round 5. Okay, now as per the algorithm, we have to select the next element. We have to take out the next element out of the unsorted list, and this next element is 10. We will take out this element here, and this element 10 is compared with the elements at position A4, A3, A2, A1, and A0, and we see that this 10 element is less than the element at position A4, also it is less than A3, and again it is less than the element at position A2, and also it is less than the element at position A1, and then we go ahead and compare it with the element at A0, but we see it is greater than the element at A0. So in this case I'll write here, since A5 is less than A4, A3, A2, A1, but greater than A0. So therefore insert A5 before A1 and after A0. Okay, which means that this element which is at position A5, the value is 10, that will be inserted between A0 and A1. So we will have a new list that is shown in the round number 6. Now in round 6, the next element is taken out of the unsorted list, and that is 15, and 15 is written here, and this element is compared with the elements in the subsorted list, that is it is compared with the element at position A5, at position A4, at position A3, at position A2, and the element at position A1. Since we see that this element at position A6, the value is 15, it is less than the element at position A5, A4, A3, A2, but it is greater than the element at position A1. So it will be placed at this place in the newly formed list. So the new list will be like this. So we can write this as a sorted list. So this is our sorted list that we have obtained by executing the insertion sort algorithm. And as you can see that in our unsorted list we had 7 elements, And for arrangement of these 7 elements in the ascending order by using insertion sort, we have to undergo for at least 6 iterations, then we will get a sorted list out of the unsorted list. Okay, now we will go through the algorithmic steps of this algorithm for better understanding, so that we will be able to write some program for the implementation of this algorithm. In this algorithm, we pick up a particular value out of the unsorted list and then insert it at an appropriate place in the sorted sublist. This is what we have already seen through the example, and that is during kth iteration the element ak. For example, we have reached to some k element in the unsorted list, and the element ak is inserted in its proper place in the sorted subarray, that is a1, a2, a3 and up to ak minus 1. So after that we insert ak by comparing the value of ak with all these elements in the sorted subarray. The task is accomplished by comparing AK with AK minus 1, AK minus 2, AK minus 3 and so on until the first element AJ. For example, the first element is represented by AJ. So we go on comparing the element AK with all the elements until we reach the first element, which is represented by aj, such that aj is less than equal to ak. So we go on comparing the element ak until we reach to the element number 1, that is represented by aj, and such that the condition is aj is less than or equal to ak. If aj is less than or it is equal to ak, if ak is less than or equal to aj, only then we will move up to this position, that is to the first element. Otherwise we would have got the proper place for ak element. Okay, then each of the element, that is ak minus 1, ak minus 2 and up to aj plus 1 are moved one position up. So we have to move one position up all the elements so that we could insert ak element at its proper place, and then the element ak is inserted in the position j plus first position. Okay, that is at the second position in the sorted sub array. So this tells all about the algorithm of insertion sort. Now for more clarity, let's go through the different algorithmic steps, as we have seen this algorithm in perspective of iteration. So in the first iteration, what happens is a1 is inserted either before or after a0. Either we can insert a1 before a0 or after a0, so that a0 and a1 are a sorted sublist. Then we take the other element, that is a2. A2 is inserted either before a0 or between a0 and a1, or it can be inserted after a1, so that the elements a0, a1, a2 are sorted. This is all what we have already done through the example. Now in the pass 3, that means in the round 3 or in the iteration 3, a3 element is taken out from the unsorted list and we insert it before a0 on the basis of comparison, or it can be inserted between a0 and a1 on the basis of comparison, or it can be inserted between a1 and a2, again it is on the basis of comparison, or it can be inserted after a2 if it is greater than the element a2, so that the elements a0, a1, a2, a3 are a sorted list. Fine. Then after doing so, suppose we reach at position at some element which is denoted as k, and for that element let me assign the iteration number k, and the element ak is inserted in proper place in the sorted subarray. That means the previous array that is already sorted, which contains the elements a0, a1 up to ak minus 1, so that after insertion of the element, that is ak, we get a0, a1, a2, ak minus 1 and ak, that generates a sorted list. Fine. And similarly, when we go ahead and we reach to the last element, we take out the last element out of the unsorted list and we insert this in the proper place in the sorted subarray, which is a0, a1, a2 and an minus 2, so that after insertion of this element an minus 1, the final list, that is a0, a1, a2 up to an minus 1, that is a sorted list. So these are the algorithmic steps that we have to follow in the insertion sort, and by using these steps we can develop a program which will implement the insertion sort algorithm. Now I'll write a function that will be called to execute the insertion sort algorithm. So let me write that function. This is a function that can be called in a program to execute or to implement the insertion sort algorithm. Now let me take the same example and we will see whether this function works for insertion sort, for sorting of these elements or not. Initially we have this example as an unsorted array, and you see on the left hand side we have written a function for insertion sort algorithm, and this function is called, and two arguments are passed. One is the array and other is the size of the array, that is n. In our case n is equal to 7. Okay, so after that here is the declaration of some variables like k, temp and j. They are declared as integer variables, and then we reach to the for loop here, where k is equal to 1 and a condition is checked whether k is less than n minus 1. N minus 1 is 6. Yes, k is less than 6, it is true. Then this loop will work, and we see temp is equal to a of k. So temp is equal to a of k means a of 1. So temp will have a value 20. Okay, and j, this line j is equal to k minus 1, which means that 1 minus 1, 0. And after that we will reach to while loop here, and this will check a condition whether temp is less than a of j. Temp is 20 and a of j means a of 0. Okay, yes, this condition is true. A of this temp, that is 20, is less than a of 0, which is having value 35. Also, if j is greater than or equal to 0, yes, it is again true. So then this line will get executed. A of j plus 1, j is 0, 0 plus 1 means 1. A of 1 is equal to a of 0. A of 0 means 35. Okay, so a of 1 will have value 35, and j will be decremented as j equal to j minus 1, and earlier we have the value of j as 0, so j will become 0 minus 1 is minus 1. Okay, then we will reach to this point and we'll go back to while loop again. Fine, and here this condition will be checked whether temp is less than or equal to a of j. Temp is having value 20. Okay, is it less than a of minus 1? A of j is a of minus 1, that is invalid. So we will come out of this loop and this statement will be executed, and here a of j plus 1, which means that a of minus 1 plus 1, which is a of 0, will be equal to temp. Temp is having value 20, so 20 will go to the to a of 0. Okay, so here this element will go here and 35 will come to this place. So the new list after this first iteration will be like 20, 35, 40, 100, 3, 10 and 15. So this would be the new list after first iteration. Then after executing this statement, you will come to this point and again go back here, and then k will be incremented, and now k will have a value k equal to 2. Fine. Here this is a0, a1, a2, a3, a4, a5 and a6. Now the value of k is 2. Then this condition is checked whether k is less than equal to n minus 1. N minus 1 is 6, and yes, it is true. Then this statement will be executed, and temp will have a value. Temp will be equal to a of k, means a of 2. So this value, that is 40, will be stored in temp. So 40 will be stored in temp, and then j will be equal to k minus 1, that is 2 minus 1. J will have value 1. Then we will reach to this place, that is while loop. In while loop, whether temp is less than a of j. Temp is 40 whether it is less than a of 1. Temp is 40 whether it is less than a of 1. Here the comparison is being made. No, this is wrong. So this will not execute on the second time, and we will come out of the loop. So here we will reach here, and here a of j plus 1, that is a of 2. A of 2 will be equal to temp 40. So a of 2 will have the value of temp 40, and so this will remain as it is. And then this loop ends here, and we will again go back to k, and the list that we get after second iteration remains same as it is. So in this way we go on incrementing the k value until this condition, that is k is less than equal to n minus 1, fails, and then we will come out of the loop, and after that we will have a sorted list. So rest of the iteration you can try yourself for your understanding. Okay, and now we will see the analysis of this algorithm for time complexity. The worst case time complexity of insertion sort algorithm occurs when the elements of the input array, that is the unsorted array, they are in the descending order. In that case we get the worst case time complexity. Now let me take the example of the same array, that is 35, 20, 40, 100, 3, 10 and 15. So here we have a list of unsorted elements, and these are 7 elements. Okay, now for second pass, when we take out this element, so for second pass when the value of k is equal to 2, then what we do is we might have to do one comparison, and we might have to shift this element. So there will be two operations performed. One is comparison and other one is the shift operation, that depends on the comparison. So that is the worst case that you have to do. So in total what you are going to do, you are going to perform two operations. When you have value of k is equal to 3, that is third pass, then you might be getting out this element from the unsorted list. Then you have to perform two operations, like two comparisons and two shifts. Okay, so you have to perform two comparisons, and also in the worst case scenario, if this element is less than these two elements, then you have to perform two shifts as well. Okay, so that's the worst case. So 2 plus 2 is equal to 4 operations. Then for k is equal to 4, you might be extracting this element out of the unsorted list. So then you have to perform the three comparisons. Okay, and you might have to perform three shifts also depending on the comparison. So that is the worst case. So here 3 plus 3 is equal to 6, so on. When you go up to nth element, then in that case you have to perform n minus 1 comparisons, and also you have to do the n minus 1 shifts. Fine, and this is equal to 2n minus 1. So this can also be written as 2 into 3. Okay, this can be written as 2 into 2, and this can be written as 2 into 1. So in total this function that is written for insertion sort can be represented as 2 into 1 plus 2 into 2 plus 2 into 3 plus so on up to 2 into n minus 1. And when I take out 2 as common out of this function, then we will be having 1 plus 2 plus 3 plus so on plus n minus 1. Okay, so this entity is nothing but the sum of first n minus 1 natural numbers. So it can be represented as 2 into n into n minus 1 upon 2. Okay, and so this function that is written for insertion sort algorithm can have the worst case time complexity as big O of n square. And now we shall see the implementation of this algorithm in the form of a program, and that we will see in the compiler. So this is all in this lecture, and I hope you understood this, and thank you for watching.